Welcome back, 8th grade. Today is day 2 of solving rational equations. All right, so yesterday we talked about finding common denominators and eliminating the denominator, and then using factoring as approaches to solving rational equations. Today we're going to look at treating it as if it were a proportion. So here you see that we have two rational expressions that have been set equal to each other. And we know that from our work with fractions that cross products are equal. The same thing would hold true here. So we could say that 1 times x would be equivalent to 2 times the quantity of x plus 4. So let's do that. 1 times x is x, 2 times the quantity of x plus 4, and now we're going to isolate the x. So here we go. X is equal to 2x plus 8. And then we could manipulate here. I'm going to subtract an x from both sides and an 8 from both sides, and we end up with negative 8 is equal to x. And of course, we want to confirm this by going back to the original equation. And we want to replace x with negative 8. And so let's just see if that works. Negative 8 here would be the same as negative 1/4. And negative 8 here would give us negative 1/4. So yes, it works. Okay. So again, when you look at this, you see that we have two rational expressions set equal to each other. So we could use cross products. 5 times a would have to be the same as 3 times the quantity of a minus 2. And so now we can multiply 3 times a and 3 times negative 2. And then, we can subtract 3a from both sides. So we're left with 2a is equal to negative 6. So a must be equal to negative 3. And the next step, we got to check, right? So we're going to replace a with negative 3 and negative 3. And so this quantity on this side is equal to negative 1. And this quantity is also equal to negative 1. Therefore, our solution is valid. All right, let's give this one a try. Now we have some binomials involved in our rational expressions, but the idea is still the same. When we have two rational expressions set equal to each other, we can use cross products. So we could do x minus 2 times x minus 4, and that would be equivalent to negative 2 times the quantity of x squared minus 4, right? Just did the cross products this way. So now we need to go ahead and multiply, gather the like terms, and you know that we're going to have to factor because there's an x squared term. So now let's go ahead and multiply the two binomials. That would be x squared minus 4x minus 2x plus 8 is equal to negative 2 times x squared and negative 2 times 4, which is positive 8. So let's gather everything to one side of the equation and set it equal to 0. So we could add 2x squared to both sides, and we can subtract 8 from both sides. And so we have 0 on the right-hand side, and we have 3x squared. And then we could gather all of these, negative 6x, and then we have negative 8 plus 8 is 0. So now we have 3x squared minus 6x is equal to 0. So you probably see that there is a common factor here of 3x. So we could factor out a 3x. We're left with x minus 2. Is that correct? Equals 0. And now we apply the zero product property. So in this first factor of 3x, if that's going to be equal to 0, then x would have to be equal to 0. And if x minus 2 is going to be equal to 0, x would equal 2. Okay, so we have x equals 2 and x equals 0, and we're going to check those solutions. So what you should see when you check your solutions is that when you put a 0 in for x, you do get a true statement. Negative 1 is equal to, oh, is that true? This should be a negative 2, sorry. There'd be positive 1 is equal to positive 1, so that works. However, when x is equal to 2, you're going to find that the denominators have a 0 in them, which is undefined. So that cannot be a solution. So x equals 0 is a good solution, but x equals 2 is not a valid solution in this case. So you may be thinking to yourself at this point, how do I decide which method to use? Because we've talked about 3 methods. We talked about common denominators in order to eliminate a fraction. We've talked about factoring, and we've talked about cross products. Here are 6 different equations. I would like you to pause the video and think about which method you might use for each situation. Okay, so this first one, I would probably tend to do least common denominator because there are common multiples. The second one, I would probably do factoring, but you probably have to do the least common denominator first and then factor it. And I know that because of that x squared term, that would be part of the least common denominator. This one, I think I would try to do cross products because it just looks like it will lend itself to that. Probably least common denominator here. I would do cross products on this one, probably. Although, you know, there may be more than one method that will work, and I definitely would do cross products on this one. So do you agree with me? Is that what you thought? All right, so today's assignment, same page as yesterday, just a continuation of problems that are probably going to be more focused on cross products, if I remember correctly, but use whatever method seems to make most sense for you. Okay, good luck.